Hello to all. Let me know, am I audible or not? Am I audible? Yes or no? Am I audible? Yes or no? Good evening to everybody. Am I audible or not? Yes. Am I audible? Yes. So let them come others. Then after I will start the session. Let them come others. Right? So within a few minutes, I am going to start this session. So don't worry. Just wait for a few minutes. In this session, as you know, I am going to give you some questions and you have to solve it, right? And hardly we take a 1 hour, not more than that. 1 hour 15 minutes max. We have to solve 10 questions within a 1 hour 15 minutes. Okay, not more than that. Got it? Because now it's time to, it's time to accelerate our speed. We have to accelerate our speed. In other words, our calculation, okay, our analyzing power, right? We have to accelerate all the thing. सर थोड़ा सा वॉल्यूम इंक्रीज कर दीजिए बेटा, यही वॉल्यूम है मैक्सिमम जितना मैं कर सकता हूँ सिस्टम के अंदर। और वैसे भी मेरी वॉल्यूम से आपको कोई मतलब नहीं होना चाहिए, आपको क्वेश्चन सॉल्व करना है। ऑन द स्क्रीन आई विल शो यू सम क्वेश्चन, देयर इज नो कंसर्न ओके विद माय वॉल्यूम. You have to worry about my volume because you have to solve the question which I am going to show on the screen, right? So let's start. There are 11 to 12 students are there. So let's start the session and here is the first question. 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 My dear student, here is the first question. Right? Here is the first question. Yes, please. Here is the first question. For a minimum work or a minimum power consumption in cutting, machining constant, that is CM equal to 90 degree. Okay, then the energy utilization in percentage is. So here is my first question which is in front of your screen and your time start now. So solve, tell me the answer. Tell me the answer. Yes, please. Yes, please. Anybody? 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 Yes, tell me the answer. What happened? What about the answer? Who tell me? Good evening to all. Just tell me the answer. For a minimum work or a minimum power consumption in cutting, okay, machining constant. Tell me the answer. Yes. What is the answer? Shall I explain? Shall I explain? Shall I tell the answer? Shall I tell the answer? Yes or no? Tell me. Tell me. Tell me. Beta, the answer is 100%. In percentage, answer is 100%. Answer is 100%. Now, you may be thinking, sir, how? Beta, the question came directly from my theory, from my notes. Okay, whatever I'm going, whatever I used to teach na, so that thing is directly from my notes. You know merchant analysis? You know merchant analysis? You know merchant analysis? Tell me. You know merchant analysis? Yes or no? In merchant analysis, you have a result. Merchant analysis result. What is the result? What is the result? Result is phi equal to. Okay. Result is what? Merchant from the merchant analysis. Tell me. 2 phi plus beta minus alpha equal to 90 degree. That is a machining constant. You proved. You have proved. And I'm not going to prove this thing here. Okay. This is the result which we got from the merchant analysis. And how we start? We start that whatever the work done is what? Cutting force into cutting velocity. So whatever the work done, we are going to deform whatever the work we are going to apply in a workpiece to break the crystal is not going to, or you can say 100% that work done is going to complete. Okay, 100% that work is going to use to break the crystal. There is no loss of work. There is no loss of work. That was the assumption in that theory. That was the assumption in that theory. And because of that assumption, you got that result. Am I clear? Am I clear? Yes or no? Tell me. Am I clear? Am I clear? Yes or no? Am I clear? Yes. To derive the merchant analysis result, that is 2 phi plus beta minus alpha equal to 90 degree, that is a machining constant. All of you know that. How that result comes? That results comes from the work done. Whatever work we are going to put into the workpiece to break the crystal, to do the machining, the work is 100% is going to transform into to break the crystal. Okay, there is no loss of work. So it comes only when there is a efficiency is what? Energy utilization is what? 100%. Yes or no? Yes or no? Tell me. I need a likes. Okay. So whoever is going to watch this session, please like this session. Right? Now, first question is over. First question is over. I hope you enjoyed that question. This is a theoretical question, but it is a typical question. Now the next question. And I hope that all of you can able to solve this question. This question is pretty simple. This question is pretty simple, and I'm hoping that all of you are able, okay, all of you are able to solve this question. So let's see who is going to solve this question. Yes, this is a pretty simple question, my dear student. This is a very, very simple question. Question number 2 is a very simple question. And I told you during the revision classes, maybe you forget or not, but I told you Yes, I told you in my revision classes. Have you seen? Yes, tell me the answer. Tell me the answer, my dear student. So those who are watching this session, I need your response. I need your response in terms of the participation. I need to like this session also. Right? Yes. So Dhruv Singh says 11. Ranveet Raj says it's 11. Akshar Jain says 11. Yes, 11 is the correct answer. My dear, what is the elongation factor? Elongation factor E. My dear, elongation factor E is your final length which obtained after the rolling divided by initial length, or you can say initial cross section area divided by final cross section area in one pass. In one pass, suppose you are doing a multiple number of passes, then elongation factor to the power n is a number of pass, initial area or final area, final length which you get after n number of pass divided by initial length, initial cross section area divided by final cross section area which you get after n number of passes. So my dear, what is the elongation factor in the question? Elongation factor in the question is what? 1.22 to the power n. Initial cross section area is 900 cross 900, 900 cross 900, am I right? Divide by 300 cross 300, okay, 300. So it's 9. So what is the answer? Shall I solve or shall I solve? Are you getting n equal to 11? Are all of you getting n equal to 11? When you solve, then approximately n will comes 11. Am I clear? Am I clear, my dear student? Yes or no? Is that question is clear? Is that question is clear? Yes or no? Shall we move? Shall we move? Yes? Okay. So let's jump to the another question. That is a question number 3. So solve this question number 3. Solve this question number 3. The coefficient of friction and the chip thickness ratio respectively are. You have to find the coefficient of friction, chip thickness ratio respectively are. Here the cutting velocity is given, rake angle is given, depth of cut is given, length of chip is given, cutting force of the tool is given, tangential force is given, and you have to find coefficient of friction. You have to find coefficient of friction. You have to find coefficient of friction. All of you know that coefficient of friction is what? Friction force divided by n. Am I right? And I hope that you got the idea. How can you solve the coefficient of friction with the help of friction and normal? How can you use these data? I mean, two data are going to be used while solving the mu: cutting force, tangential force, and the rake angle. There is a famous relation which I told you in my revision classes. There is a famous relation I told you in my revision classes. I gave you some relations by which you can directly solve. This is 0.6, my dear, comma. And I think the coefficient of friction. Yes. Yes, the coefficient of friction, my dear. Yes. Shall I solve? Shall I solve? Okay, tell me the chip thickness ratio. What is the chip thickness ratio? First of all, chip thickness ratio is what? T naught by Tc or Lc by L naught. Am I right? First of all, am I right? So, my dear, Lc by L naught. Lc is what? The length of the chip. Length of the chip is given. That is 60 mm. 60 mm. Right. Divide by L naught. L naught is what? Pi d. L naught is what? Pi d. Am I clear? Am I clear? So, here chip thickness ratio is 60 divided by pi into d. Diameter is what? Diameter is given. Direct turning propagation seamless 32. 32. So, what is R? What is R? 60 divided by shift pi into 32. It is 0.59. 0.59. 0.59. Okay. But directly you can see R equal to 0.59 or R is approximately 0.6. Only one option is there. Only one option is there. Now, you know the R. Can you find other thing? Answer divide by shift pi by 2. Pi by 2. Yes. Yes. So you can say directly D is your answer. Right, directly D is your answer. But there is one thing. There is a one thing. My dear, you can say D is the answer. My dear, listen me carefully. Listen me carefully. Listen me carefully. Actually, here the options are little bit wrong. Can mu is greater than 1 possible? Tell me. Can mu is greater than 1 possible? Yes or no? Can mu greater than 1 possible? Tell me. Can mu greater than 1 possible? Yes or no? Yes or no? Can mu greater than 1 possible? Can mu greater than 1 possible? Yes or no? Tell me. So how can you say that D is your answer? How can you say that D is your answer? Actually, I will tell you one thing. Actually, this question will not come into your exam, don't worry. I was solving ESC conventional question in 80s. Okay, there was a question in 1980 or 84. There was a question. When mu is greater than equal to 1, when you are getting mu is greater than equal to 1, then this formula is not applicable. Then this formula is not applicable, my dear. In that case, you have to use classical friction theorem. In that case, you have to use classical friction theorem. When mu is greater than 1, when mu is greater than 1, in that case, use classical frictional theorem. But this is not mentioned in your GATE exam. Okay, that's why I'm avoiding. This is not mentioned in your GATE. Okay, that's why I'm avoiding this. And what is that classical friction theorem? Let me tell you. Classical friction theorem is mu is ln 1 by r divided by pi by 2 minus alpha. Alpha should be in radian, right? Alpha should be in radian. So according to that, the mu will be what? Ln 1 by r, and r is what? R you are getting 0.59. 0.59 divide by pi by 2 minus alpha by 2. Alpha should be in radian. You know that 180 degree equal to what? Pi. Then 35 degree equal to what? Pi into 35. Okay. Pi into 35 divided by 180 degree. Am I clear? So let's solve here. Let's solve. Right? Minus shift pi into 35 divided by 180. So my dear, here it will become 0.53. My dear, here it will become 0.53. I know the option is not there. It's my mistake. It's purely my mistake. Option is not there. If I place, actually, the answer is, if I am going to correction, that is 0.53, okay, and 0.6. Am I clear? Am I clear? But the thing is, this classical friction theorem is not mentioned in your GATE exam. This classical friction theorem is not mentioned in your GATE exam, right? So just forget this, it's my mistake. Actually this question is made by me. Unfortunately, I put this data in such a manner, where I am getting mu is greater than 1, right? Right? You have to always use this, because in GATE exam, classical friction theorem is not mentioned in your syllabus, okay? And the GATE exam never asked classical friction theorem. So don't worry about that. It's my mistake. It's my mistake that I put a wrong data, okay, in the question. That's why you are getting mu is greater than equal to 1. Am I clear? So it's my mistake. If all of you are not able to solve this question, all of you will get plus marks from this in this question, right? Am I clear? Am I clear? Just forget classical friction theorem, because GATE never asked classical friction theorem. By mistake, I put the wrong data. That's why you're getting mu is greater than 1 from F by N, right? It's my mistake. So just leave this question. Now this question number 4. Question number 4. But suppose that if this happen, that mu is greater than 1, then in this way you can solve this, right? In this way you can solve this. Suppose that if by mistake in some other exam you are getting mu is greater than 1, in other exam if you get mu is greater than 1 by F by N, then you apply classical friction theorem, right? Now solve this question. In drilling operation under a given condition, the tool life was found to decrease from 20 to 5 minutes due to increase in drill speed from 200 RPM to 400. Okay. T1 and V1, or you can say N RPM, that is N1, T2, N2. 20 minutes to 20, okay, let me write down in a clear manner. Yes, what is the question? T1 equal to 20 minutes, it goes to T2 5 minutes when you increase the speed, okay, 200 to 400, that is N1 200 RPM to N2, that is 400 RPM, right? What will be the tool life of that drill under the same condition if the drill speed is 300 revolution per minute? Yes, tell me please. Yes, right. The value of tool life is 8.88 minutes. Right, the value of tool life is 8.88 minutes. Let me solve this question in a very short manner. My dear, here you can write N1 T1 to the power N, N2 T2 to the power N. Okay, here N1 is what? 200 into T1, that is what? 20 to the power N. N2 is 400 into T2, that is 5 to the power N. When you solve, then you will get the value of N. When you solve, then you get the value of N. So what will be the value of N? N will be 0.5, right? N will be 0.5. So when you place N1 T1 to the power 0.5, N3 T3 to the power 0.5. So N1 you know that 200 and T1 is 20 to the power 0.5, N3 is 300 RPM and T3 is, you have to find T3 to the power 0.5. It will becomes T3 equal to 8.88 minute. Am I clear? Am I clear? Yes, very right. Now, the next question. Now, the next question. Next question, please. You have to find the maximum and average chip thickness in milling, right? You have to find maximum and average chip thickness in milling. Yes, please. Yes, what is the maximum and average chip thickness? Do you know the formula or you forget the formula? Have you forget the formula? These two options, yes, yes, yes. My dear, tell me, T maximum always greater than T average, na? T maximum always greater than T average, na? Yes or no? Tell me. So how can it possible that maximum is less than average chip thickness? Maximum is less than average chip thickness. So this is not my answer. This is not my answer. First of all, two options are eliminated. Two options are eliminated. So you can find the T average What is T average? T average is Fz. T average is Fz root of depth of cut divided by milling cutter diameter. But you don't know the value of Fz, but you know the table speed, that is capital F equal to Fz into number of teeth into what? RPM, right? And here RPM is given. RPM is given or not? Here RPM is also not given. Here the cutting speed is 30. This is given. So cutting velocity is pi dn divided by 1000, right? So V is 30 and pi, diameter of the milling cutter is, dia of the milling cutter is 90 into n, right? Divide by 1000 equal to 30. So you will get what? RPM. So 30 into 1000, answer divide by 90 into shift pi. Here the RPM is 106.103 revolution per minute. So just put here the cutting feed, table feed is 180 mm Fz into Z. Z is the number of teeth. Number of teeth is 10 into 106.103. So 180, okay, divide by 10 into answer, it comes, Fz comes 0.1696, right, mm per tooth, So what is T average? T average is 0.1696 root of D, depth of cut. Depth of cut is what? 3 divided by 90. Answer into root of 3 divided by 90. So it is 0.03. So twice of that is T maximum. Right? Am I clear? Okay. Let's move to the another question. Number of pulse required. Here, 3-axis table, the slide along the vertical axis driven by a DC servo motor lead screw. The lead screw has a pitch of 3 mm. This lead screw is fitted with a relatively circular encoder. The basic length unit of the vertical axis is 0.005 mm. When the table move along the axis by 9 mm, the corresponding number of pulse generated by the encoder is, right? The corresponding number of pulse generated by the encoder is. My dear, here you know the initially basic length unit is what? Basic length unit is 0.005 mm, right? This is basic length unit. And what is pitch? Pitch is 5 mm, right? You know that BLU equal to pitch divided by, in terms of formula, BLU, pitch divided by number of pulse per rotation. So here you will get number of pulse, okay, per rotation. That is what? BLU. Okay, pitch, that is 5 divided by what? 5 divided by 0.005. It will become 1000 pulse. Am I clear? It will become 1000 pulse. You can say, my dear, that 5 mm, for 5 mm linear motion we need how many pulse? 1000 pulse. Am I right or wrong? Am I right or wrong? For 5 mm linear motion, we require 1000 pulse. So for 9 mm linear motion, how many pulse we required? That is 9 divided by 5, answer into 1000, that is 1800 pulse. 1800 pulse are required. Sorry, yes, 1800 pulse are required. Am I clear? So what is the answer? It is not answer is not D. This is your B. Am I clear? Dhruv Singh, Vishal Tyagi, Akshat Jain. Yes, you gave answer, you gave option D, but the actual answer is option B. Am I clear? Am I clear? Yes or no? Am I clear? Yes or no? Yes, please tell me. My dear student, are you getting this? Are you getting this? How 1800 pulse are coming? How 1800 pulse are coming? Are tell me, re Baba, are you getting or not? Are you getting or not? Getting na? Are beta, simple. For 5 mm linear motion, we need 100 pulse. Then for 9 mm linear motion, how many pulse are required? Simple. Hai? It's a 10 plus 2 mathematics. It's a 10 plus 2 mathematics. For 5 mm linear motion, we need 100 pulse. Then for 9 mm linear motion, how many pulses are required? Huh? How can you find out? This 9 into 1000 divided by what? 5. Then it comes what? 1800 pulse, na? 1800 pulse, na? Yes or no? Okay, Vishal Tyagi. Yes. This question I explained. This question was explained in your revision class. Do you remember? This question was explained in your revision class. Yes. Yes, 7th question, and it's 6:40. 20 minutes left. 20 minutes are left for this session. Electrolyte flow rate, how can you find? How can you find the electrolyte flow rate? Mass of the electrolyte flowing per second into a specific heat of the electrolyte into change in temperature, heat that is produced in the electrolyte which is present in the gap, and it is what? Tell me. I square R. I square R. I square R. Re, sorry, Re is the resistance of the electrolyte which is present in the gap. Yes or no? So, tell me, is that concept is clear? Mass of the electrolyte flowing per second into specific heat of the electrolyte into change in temperature equal to what? Heat produced in the gap, that is I square Re. Now, mass of the electrolyte, that is density of the electrolyte into volume of the electrolyte flowing per second, okay, into CE. You can write mass of the electrolyte flowing per second into what? Density of the electrolyte into flow rate of the electrolyte per second. Okay. Change in temperature, I square Re. Now, what do you have to find? You have to find resistance. You have to find, my dear, resistance. So, what is resistance? How can you find the resistance? Resistance of the electrolyte is a specific resistance of the electrolyte, length of that gap, cross-sectional area of the electrode. So, a specific resistance of the electrolyte is given. Yes or no? Is that given? That is 3 ohm centimeter. 3 ohm centimeter into L, inter-electrode gap, because the current is flowing, okay, in between the gap, and the gap is behave like a current carrying wire. So, inter-electrode gap, the gap that is 0.25 mm, so it will be 0.025 centimeter, right? Cross-sectional area is 25 mm cross 25, so it will be 2.5 square centimeter square. Am I clear? So, here you will get the resistance of the electrolyte. Okay, resistance of the electrolyte, and what is the value? The value will be 0.012, my dear. The value will be 0.012 ohms. Am I clear? Am I clear? Now, this is the resistance of that electrolyte through which the current is passing and where the heat is going to be what? Produces. What? Right. Now, current is given to us. Yes or no? No, current is not given to us. So, how can you find the current also? Current, you can find current density into a specific resistance of the electrolyte, V minus delta V divided by Y. Am I clear? By this formula you can find, or by this formula you can directly find. What is that? This is V equal to IRE. V equal to IRE. Voltage, applied voltage is what? 12 volt. I is what? I you have to find, and I is what? 0.012. Am I clear? So, applied current will be 1000 ampere. 1000 ampere. Okay. Now, you have the resistance of that electrolyte through the current is passing through. You have the value of current. You have the value of resistance. You have the value of current. Now, specific heat. Here, specific heat is given 0.99 calorie per gram per degree Celsius. My dear, you have to convert into what? Into, tell me, it is given in calorie, you have to convert into joule. So, 1 calorie is what? 4.184. So, specific heat of the electrolyte. Specific heat of the electrolyte is 0.99. So, 4.187 into 0.9997. It will be joule per gram per degree Celsius. Right. Now, what is the density of the electrolyte? Tell me. What is the density of the electrolyte? My dear, here the electrolyte generally is what? Diluted. Diluted. Okay, diluted electrolyte. Diluted salt water. NaCl. NaCl dot H2O. NaCl dot H2O. And I told you, when the electrode, when the electrolyte is diluted, okay, when the electrolyte is diluted in electrochemical machining, its density is what? Approximately equal to density of what? Water. And you know, density of water in gram per centimeter cube is what? 1. In gram per centimeter cube is what? 1. And in kg per centimeter cube is what? 1000. Am I clear? Am I clear? Now, so put the value here. Put the value here, my dear. Put the value here and solve this thing. Okay. And solve this thing. That is density of the electrolyte 1, flow rate of the electrolyte which we have to find out, okay, into a specific heat, that is 4.187 into 0.997, that is a specific heat, into change in temperature. Here the ambient temperature 95 minus 35 equal to I square, that is what? 1000 square into Re, that is 0.012. Am I clear or not? Tell me, am I clear or not? Yes or no? Are you getting this thing? Are you getting this thing? Are you getting this thing? Are you aware this? Are you aware with this concept or not? I told you in the revision classes. Okay, so here the flow rate of the electrolyte is what? The flow rate of the electrolyte is 47.99 centimeter cube per second. Okay, here I have to mention flow rate should be centimeter cube per second. I have to mention that flow rate should be centimeter cube per second. Then what is the value? No, Ravneet, it is 47.99. It is not a 3 digit, it will be a 2 digit in centimeter cube per second. Am I clear to all? Am I clear to all? Is that concept is understood? Is that concept is understood? Shall we move? Okay. Next question. It's a direct question, my dear. It's a direct question. This question I'm not going to solve. This question I'm not going to solve. Right? This question I'm not going to solve. 110 times I told you. In my revision class I told you. Yes. For maximum power, this is a very good question. Sorry, this question is a very good question. Please focus on that line for a maximum power. Please focus. Instantaneous capacitor voltage during charging for a maximum power. For a maximum power. My dear, there is a relation for maximum power. For maximum power, instantaneous voltage for the capacitor, that is VC, equal to what? 0.72. 0.72 times of what? V naught. Am I clear? This question is totally new. This question is totally new. He is asking maximum power. So please remember this relation. This is a derivation. This is a derivation for maximum power. For maximum power, this is the relation. VC equal to 0.72 times of V naught. This is the derivation. Am I clear or not? Am I clear or not? Okay, this is the new question. Okay, the GATE will ask, the GATE exam, the GATE will ask this type of new question. So, what is a VC? VC is 0.72 times of supply voltage, that is 220 volt. Right, 220 volt. So 0.72 into 220, it's 158.5. Ha! VC is 158.4 volt. Am I clear? Am I clear? Am I clear? Yes or no? Am I clear? Yes or no? Tell me, Baba, am I clear or not? Is that concept is clear? Is that concept is clear? Now, the next question. This question I am not going to solve. Yes. This question I am not going to solve. This is a very, very easy question. This is very, very easy question. Yes. This question I am not going to solve, remember. Yes. What is the answer? 415. Yes, almost all are giving the right answer. Almost all are giving the right answer. Yes, my dear. The answer is 415. 415. Right? Or 415.8 megapascal. 0.8 megapascal. And you know the applied formula? What is the applied formula? That is A naught. Applied formula, that is A naught sigma naught ln A naught by A final. And you know A naught by A final is what? Extrusion ratio. And here extrusion ratio 4 is given. So directly you have to put extrusion ratio A naught by A final. A naught is given, sigma naught is given. Okay. Now solve this question. Yes. Solve this type of question. Percentage utilization of the strip. Given that an equilateral triangle of 50 mm on each side is required to be produced from a sheet, take the value of front scrap, back scrap and scrap bridge as 2 mm. The percentage utilization of the strip is. My dear, the formula is very simple. This type of question was asked in the last GATE exams. Okay. So the percentage utilization is the percentage utilization is area utilized right, area utilized divide by total area of sheet. Total area of sheet. Total area of sheet. Am I clear? Am I clear? Am I clear? So suppose that here this type of see here, just focus on this portion. In this sheet you are producing this blank from this sheet. So what is the area utilized divide by total area of the sheet? Am I clear? Divide by total area of what? Sheet. Divide by total area of what? Sheet. Will you solve this question? Will you try by yourself or not? Tell me. My dear, tell me. Will you try this question by yourself? Take the screenshot. Take the screenshot and try this question by yourself. Take the screenshot, my dear student, I'm not going to provide the PDF of this session, so it is better that you should take the screenshot of this question and try by yourself. Try by yourself. Here the answer is option A, try by yourself. Okay, this is the applied formula, area of utilization divided by total area of the sheet. Am I clear? Will you try by yourself? Yes or no? Will you try by yourself? Will you try? Okay, take the screenshot. Now, solve this question. I know the name of the session is my 10 question, but I'm going to solve more than 10 questions because one question I gave you as a homework. So technically I have discussed only what 9 questions. So that's why I'm going to solve some more questions, right? Because already we have a 2 minute left, so we can at least try. The thickness of a plate reduced from 40 to 20 by successive cold rolling means you are doing a rolling operation, and by successive cold rolling you are reducing from 40 to 20. So the delta H required is what? 40 to 20, that is 20 mm. But in one single pass, maximum reduction which is possible is what? Mu square R. Mu is 0.1 square into R, that is 300, so it comes 3, right? 3 mm, it comes 3 mm. So it is understood that from one pass, yes sir, okay, you are getting 84%. Congratulations Avneet Raj. Congratulations Avneet Raj that you are getting 84%. Okay, other, please try this question. So you know maximum reduction, number of passes are what? Delta H required divided by delta H max, right? So delta H required, that is 20, and delta H max, that is 3. So approximately 7 will become, right? Basically it comes 6.67, but nearby 7 will become. Okay, one more question. One more question. Last question of this session. Last question of this session. T, the suitable shear angle you have to find here. 30 T, T stand for what? Tons, and 1 ton equal to 9.81 kilonewton. 1 ton equal to 9.81 kilonewton. He says that when you apply the shear, that is Fs, and you know Fs, F maximum into percentage penetration into thickness, divide by shear plus penetration thickness into T. When you give the shear on a punch, then the force will comes to 30 ton, and 1 ton is 9.81 kilonewton. F maximum PT divided by S plus PT. Am I clear? Am I clear? Yes or no? So what is the F max? F max is perimeter into tau into T naught. What is the perimeter? Pi d into tau. Tau is what? Tau is 550 into T naught is 5.6. Am I clear? It is 5.6. So pi d is basically here pi d is 100. Again I am writing 550 into 5.6. So shift pi into d into 550 into 5.6. Answer divided by 1000. It is 967. It is 967.61 kilonewton. Right, kilonewton. And it is also a kilonewton, 9.81 kilonewton. So 30 into 9.81 kilonewton equal to 967.61. Percentage penetration is 40. So 0.4 into 5.6 divide by S plus 0.4 into 5.6. You will get the value of shear. Yes or no? So here the answer is, my dear, here the answer is answer into 0.4 into 5.6 divided by 30 into 9.81. Answer minus 0.4 into 5.6 here, sorry, 5.6. So here shear is 5.12 mm. Here the punch is what? Circular. Here the punch is circular, my dear. Okay. So when you give the shear, right, see here, right. So this is the shear height. That is 5.12, and this is a shear angle. This is the diameter D, 100. So you can find that theta S equal to tan inverse 5.12 divided by 100. So here the answer is 2.93. Yes, 2.93 degree. Right? So don't worry. On the main channel we are going to meet and some other extra question I am going to solve. Right? Some other extra question. Sir, can you please show the 10th question and zoom it, please? Yeah, sure. No issue. Please take the screenshot. This is the applied formula. Area utilized divided by total area of sheet. Right? Rishabh Kumar, you can take the screenshot of this question and solve by yourself. You will get 84%. Applied formula is area utilized divided by total area of sheet. And if you are not get the answer, don't worry. On the main channel, again I am going to take my 10 question. Okay, my 10 question I am going to again take on the main channel. If you are not able to solve this question, again I will explain this question only, not other. I will bring some other extra questions also. So totally I am going to provide more than 20 to 25 questions in production. Am I clear? From my side, you will get more than 25 question or 30 question. Right? Today we have solved 12 question. On the main channel, that is on I think 2nd Feb. On the 2nd Feb, again I will bring my 10 question. In that session, again I am going to discuss 10 to 12 question. So you will get from my side 24 to 25 question in production. Right? Same in industrial also. On the global channel, I will bring more than 10 question. On a main channel, again I will bring more than 10 question. So in industrial engineering you will get more than 20 questions from my side. Clear? Clear? So okay, thank you for watching this session. We will meet in the other session. Thank you.